We have now the chance to approach to open the last presentation, which will be then delivered by Jacek Kościukiewicz from CAMBI organization. His presentation is about municipal sludge as a product in circular economy.
I would like to say a few words about the how we can consider the municipal sludge which is produced in the wastewater treatment plant in the age of the circular economy. So I would say that my story begins very long ago. There were just a few people on the Earth, and our planet was able to recover from all injuries which we caused. The more we were possessing the Earth, the more difficult its recovery was taking, until we have reached the point of no return. So this means that we should do something, otherwise our successors will not have the place to live. And to do that, the international community decided to change it, to change the way how we use the Earth and its resources. And the circular economy is just one of the many ways which we want to use to make sure that we will leave our planet for our successors. The definition of the circular economy developed in the European Parliament states the following. The circular economy is a model of production and consumption which involves sharing, leasing, reusing, repairing, refurbishing, and recycling existing materials and products as long as possible. So there was developed the framework model by the authors, Small et al. And I will mention the source later. And this framework model says that the model is developed particularly for the water and wastewater treatment sector. And the model assumes the 6 R's, and the first R is the reduction. It is the prevention of the wastewater generation by reduction of water usage and pollution at source. That was already mentioned before. The next is the reclamation, which is the application of effective technologies for the removal of pollutants from water and wastewater. The following is the reuse. We can reuse the wastewater as an alternative source of water supply for the non-potable usage, and it was also mentioned before. We have also the next R, which is recycling, the recovery of water from wastewater for potable use. It's also mentioned before. Recovery of resources, such nutrients and energy from water-based waste. And finally, the last but not least, it's also very important, rethinking how to use the resources to create a sustainable economy, which is free of waste and emissions. This is the source, if someone would be interested in the details of this framework model. There are several things we may recover from our waste water. Let's just mention a few of them. That's the most common, nitrogen and phosphorus, but also the other, like the cellulose, the humic acids, fatty acids, enzymes, or polysaccharides. Some technologies already exist and are quite commonly used, and some still require improvement because they are present in the prototype state. The biocore recovery technology exists also, but it is at the present time used in rather small plants. What I would like to focus on are the biofertilizer, electricity, and heat. The anaerobic digestion of municipal sludge is widely known and commonly used, so I will not go into details. The both primary and waste-activated sludge are mixed and sent to the digestion chamber. Then produced is biogas, which is burned into cogeneration and what produce the electricity and heat. As we see, the conventional anaerobic digestion process gives us three precious products: electricity, heat, and final sludge. This is the place where the final sludge is produced. In general, there are two groups of final sludge disposal. The first one is the thermal applications, and the second is the land application. At present time today, I will not discuss the thermal applications because it's only matched partially the concept of the circular economy. I will rather focus on land applications. The sludge directive regulates conditions of using the sludge in agriculture. Among the other things, it describes conditions of the application, reporting obligations, and from the important thing from the processing point of view, the limits related to heavy metals. However, of course, we shall remember that heavy metal content in the biosolids is the consequence of their content in the raw sludge and the quality of the wastewater treatment. The anaerobic digestion does not change metal content, but it increases its concentration due to the reducing of the sludge amount. Then we have the fertilizing regulation. Among the other things, it also covers the use of the biosolids. I mentioned just the most important regulation, but there are, of course, several which we have to comply. And what can we do to comply with all those regulations? We may try to enhance the anaerobic digestion process, which has basically the 4 steps which occur one by one. The process is probably perfectly known for you, so maybe it is not necessary to repeat it. However, there is some purpose which I would like to mention. That the steps of the anaerobic digestion are hydrolysis, acidogenesis, and finally the methane genesis. And like all chemical processes which consist from the individual sub-processes, kinetics of the slowest sub-process determines the kinetics of the whole reaction. And in this case, the slowest sub-process is the hydrolysis. So the conclusion is that if we can increase the rate of hydrolysis, then we can increase the whole process of the methane fermentation. And for this purpose, we developed the process which is called thermal hydrolysis. The combination of the thermal hydrolysis and conventional anaerobic digestion gave the process which we called advanced anaerobic digestion. This name was created by the United Kingdom utility company, which holds several water and waste water treatment plants. The company name is Thames Water. And in this case, the sludge is pre-dewatered, and then it is going to the thermal hydrolysis process. The centrate from the pre-dewatering is sent back to the plant, and the hydrolyzed sludge after dilution is sent to the digestion. And as previously, the biogas produced in the digestion process is burned in the cogeneration unit, but it also could be upgraded to the biomethane and loaded to the gas network. The rest of the process is the same. The electricity is produced and heat. The heat is used to produce steam necessary for the thermohydrolysis process. The sludge after digestion is dewatered. The centrate is again sent back to the plant, and as a product, we are receiving the biosolids. Let me now show you how the thermohydrolysis process works. The sludge, it could be a mixed sludge, but it could be separate, for example, only the surplus, is pumped to one of the 4 reactors after the preheating with the recovered steam. And then the sludge is cooked with the steam in the temperature of about 165 degrees Celsius and under about 6 bars pressure. And after that, there is a rapid discharge to the tank, which is called the flash tank. And then there is the rapid depressurization from 6 bars to the atmospheric pressure. So there occurs the process called the steam explosion, which additionally disrupts bigger particles. So this is the advanced anaerobic digestion. This slide already presented to you, and we call it the full CAMBI process because it hydrolyzes both the primary sludge and the surplus sludge. But it is not the only solution. There are possible also the other setups of the process where we only hydrolyze the waste activated sludge, and after the pre-dewatering to about 16 to 18% of dry solids, the sludge is hydrolyzed and sent to digestion. Then the primary is added, and this is because the primary sludge fermentate quite well without the thermohydrolysis due to its chemical composition. Then, like previously, we produced the biogas and all the other things. There is no difference to the standard conventional anaerobic digestion. And again, we are receiving as a product the biosolids. The difference is between these two processes that the full CAMBI process sterilized the whole sludge before digestion, while the was only process sterilized only the surplus sludge. And so depends on the final disposal of the process, we may use one of the or the other. There is also recently developed the process which is called the intermediate thermohydrolysis, where if we have available digestive volume, we can have the first digestion step followed by the hydrolysis and followed by the second step of digestion. And finally, currently at least, the process which is called the CAMBI solid stream. And in this case, the hydrolysis takes place after the digestion, and the centrate from the final dewatering, which consists a lot of COD, which later on can be transferred into the methane, is sent to the first digestion step. This is the comparison of the different processes. The first obvious conclusion is that it reduces the thermohydrolysis reduces the necessary digester volume, and the last two can be used only if there is existing available excessive volume of the digesters. So how the biosolids produced in the advanced anaerobic digestion fits to the circular economy concept. As I already mentioned, the current fertilizing regulation in European Union allows to use the biosolids as the natural fertilizer. But of course, these member states can implement the different regulation. And the example here is Germany, where using biosolids as the fertilizer is forbidden, and only incineration or core incineration is currently allowed. But for example, in the countries out of European Union, like Norway, United Kingdom, USA, Canada, or Australia, the biosolids are commonly used as the biofertilizer. So let's say answer the question how the thermohydrolysis fits the concept of circular economy. So the first, it stabilized the sludge already, so no any additional step is necessary. It reduces the volume of the final sludge for disposal. This is because the hydrolyzed sludge is much easier to dewater comparing to the conventional process. It hygienizes the sludge because there are no pathogens which can survive such a high temperature and high pressure. And finally, we can recover the energy, energy from the sludge, and reclaim the biosolids and use them as biofertilizer. So last but not least is a tremendous lowering of the carbon footprint. Again, so that's still 2 minutes, so I'm going to the end. The biosolids produced in the advanced anaerobic digestion produces the fertilizer, which is pathogen-free, odor-free, is easy to apply, it's natural, and because it is easy to apply because of the dry solid content in comparison with the sludge which is produced in the conventional anaerobic process. It contains several nutrients which could be successfully returned back to the environment. So that's all from my side. We produce the power from the people and the biofertilizers. So thank you very much for your attention.
Jacek, thank you very much for your presentation. I just checked the slide. No questions to your presentation. I might mention one question. Could you describe a little bit more the market potential of the products you have presented related to the activities of your company?
But you mean the market for the anaerobic digestion process, or the market for the biosolids as the final product?
Biosolids.
As the biosolids.
Yeah.
I must say that, for example, that depends on the country, because, like I said, even if the European regulation allows to use it, allows to use the biosolids as a biofertilizer, there are different internal regulation in each member state. For example, in Poland, about 50% of the sludge is used in agriculture, and partially for the crops for food, and partially for the soil improvement in the forestry, lawns, and this kind of places. In Norway, over 90% of sludge is used in the agriculture and soil improvement processes. In Germany, there, as I said, no sludge is used for this purpose. In European Union, Germany is exception because it is necessary to burn the sludge either in the incineration plants or the cements, the power plants, this kind of processes. So another example, we built the advanced anaerobic digestion with thermohydrolysis in Beijing. There are five wastewater treatment plants for the 20 million people, and all of them uses the thermohydrolysis, and all the sludge is used in the agriculture. So there is no simple answer. However, currently, the trend is to use the biofertilizers more and more.
Thank you, Emrah. Thank you very much. If there are no other questions, then we can come.
I see there is one question.
Josef Tregel has a question, I see.
Sorry, it took me some time to find how to raise hand electronically.
In the electronic way?
Yeah. I just wanted to ask whether have you somehow tried to estimate what proportion of the recycled material or what proportion of the standard, let's say, materials can be substituted by this recycled wastes from the sludge? For example, how much of inorganic phosphorus, which is used as fertilizer very in high quantities, both here and as well as in Poland, can be substituted by the recycled phosphorus from this sludge? Because I don't have the data, but I'm afraid it will not be a high percentage, maybe 10-20%. The same, for example, for the energy.
Talking about the nutrients, yes, there exist several studies which analyze the necessary amount of the, in this case, nitrogen or phosphorus. I don't remember the exact data by heart right now. However, it is true that there is only some percentage, and in several cases, the addition of other fertilizers is necessary. Typically, the inorganic fertilizer. So I cannot say that it replaces completely the application of inorganic fertilizers, but definitely it reduces the amount of them which are introduced to the environment. If you are interested in detailed studies, so you may just send me an email, and I will provide you with some examples of the scientific publication related to this process.
Yeah.
Thank you very much for your answer, Josef. Last question.
I think I can find the literature. I was more likely interested in your personal opinion, especially Poland is in a very agricultural country.
Yeah, that's the process is, I would say, centrally managed by the Institute of the Soil Improvement and Fertilizing in Puławy in Poland. And they made several studies related to the sludge, treated sludge application, and issued the certificates and detailed procedure of the implementation. So it depends on the content of the nutrients in the soil, the heavy metals in the soil and heavy metals in the sludge, the content of the nutrients, and so on. So individually, the procedure of application is in detail developed for the particular area of land. And I should say that the demand for sludge, for treated sludge in Poland is so huge that the wastewater treatment plants could produce the maybe 40 or 50% more than it is producing, and the demand from the farmers would be satisfied in this after that.
Okay, I might add the question. The export of sludge from Germany, it's not allowed, it's prohibited.
No, not because we don't want it, but because they don't want to sell it.
Yeah. I am very sorry to stop this interesting discussion. Thank you very much.
Thank you.
I might say some final words. We had 6 presentations, 6 speakers. They looked at the issue of wastewater from different perspectives. So we got really an interdisciplinary picture, interdisciplinary competence. I would like to thank to all speakers especially for the high degree of time discipline. We have still very hard time with online communication, but we managed. I would like to thank organizers, especially Lea Turcarova from the Nordic Chamber, and last but not least to both IT experts in the background. They provided us the comfort of online communication. Thank you very much. I hope see each other next time.